In this video, we're going to talk about 7.3.1, which is our first translation theorem for Laplace transforms. And it's going to be translations on the s-axis. The proof of this is very straightforward and is in your textbook, so I'm not going to go ahead and write it here. It's really just like a one-step proof. So we have t e to the 10t, and it's this e to the at right here that is the translation. Then we're going to look at what would the rule be for the Laplace transform of t, and it would be 1 over t squared, but I'm going to replace the t with a set of parentheses, and sorry, it would be 1 over s squared, and we're going to, in the parentheses, put s minus this a value, so s minus 10. Okay, let's go ahead and look at number 3. And it says Laplace transform of t cubed e to the negative 2t. So we're going to have 3 factorial over something to the 4th power, and that something to the 4th power is going to be s plus 2. 3 factorial is 6. S plus 2 to the 4th. Problem here is going to be Laplace transform of t times quantity e to the t plus e to the 2t squared. I'm going to need to expand that before I begin. Laplace transform of t, and inside here e to the 2t plus 2 e to the 3t plus e to the 4t. Then let's break each of those up. So this is Laplace transform of t e to the 2t plus 2 Laplace transform of t e to the 3t plus Laplace transform of t e to the 4t. And that becomes, for the t, this is normally 1 over s squared. This is going to be s minus 2. We have a constant multiplier of 2 times, and then again, t is normally something squared in the denominator. So that's s minus 3 plus, and then again, normally something squared in the denominator. This is s minus 4. So erase that. Let's look at number 7. That's the Laplace transform of e to the t sine of 3t. And so sine is normally k over s squared plus k squared. That s gets replaced with s minus 1. That's all they want you to write. They don't want you to expand that. 9 is Laplace transform of 1 minus e to the t plus 3 e to the negative 4t. This is all in parentheses. Cosine of 5t. So we have Laplace transform of cosine 5t minus Laplace transform of e to the t cosine 5t plus 3 Laplace transform e to the negative 4t cosine 5t. And that's going to be s over s squared plus 25 minus, and then the s's are going to get replaced with parentheses here. And in their place goes, this time, s minus 1, and then plus 3, and then s's get replaced with parentheses here. And it is s plus 4. For that one. Let's go ahead and look at some inverse Laplace transforms now. That have been transformed. So we're on number 11. That's inverse Laplace transform of 1 over s plus 2 cubed. So this is 2 plus 1 down here. I need a 1 over 2 factorial, inverse Laplace, 2 factorial over s plus 2 to the 2 plus 1 is the rule that I need to be looking at. So 1 over 2 factorial is 1/2. And then this is going to come out to be t squared e to the negative 2t. Number 13. This is inverse Laplace transform of 1 over s squared minus 6s plus 10. So I'm going to make that inverse Laplace transform of s minus 3 squared. That's plus 9, so there's an extra plus 1 left. That 1 is perfect because that's my k value. So this is sine of t, and this is e to the 3t times that. 15 is inverse Laplace transform of s over s squared plus 2s plus 5 is inverse Laplace transform of s plus 1 squared. That leaves me with plus 4 here. And right now there's just an s. I need to make this plus 1 and minus 1. So this splits up into inverse Laplace transform of s plus 1 over s plus 1 squared plus 4. And that minus inverse Laplace transform of 1 over s plus 1 squared plus 4. But my k value here is 2. So I need to, wait a second, I wrote this wrong. This is not, this is not a 2, this is a 4. I still could have done the problem the way that I was doing it, but this is 2 squared and then plus 1. So 2 and minus 2 makes this fit perfectly. Plus 2 plus 1 is 1, and I'll pull the 2 out. So this is cosine of 2t, and it's an e to the negative 2t multiplied. It's a 1. Cosine of t minus 2 sine minus 2e to the negative 2t sine of t. Sorry, I started writing down number 14 instead of number 15. So let's go ahead and look at number 17. Inverse Laplace transform of s over s plus 1 squared. So I'm going to want inverse Laplace transform s plus 1 minus 1 over s plus 1 squared. It's going to make this inverse Laplace transform of 1 over s plus 1 minus inverse Laplace transform of 1 over s plus 1 squared. And so that's going to be e to the negative t minus t e to the negative t. I'm going to do number 19, and I'm going to use technology behind the scenes and I'm going to show you where I did so. It's a bit of a bear of a partial fraction decomposition problem. So inverse Laplace transform of 2s minus 1 over s squared times s plus 1 cubed. And so for partial fraction decomposition, that's going to be the constant a over s plus the constant b over s squared plus the constant c over s plus 1 plus the constant d over s plus 1 squared plus the constant e over s plus 1 cubed. And that's going to be equal to 2s minus 1 over s squared times s minus 1 cubed. So that gives us a times s. This is plus 1 cubed. So b times s plus 1 cubed plus c s squared times s plus 1 squared plus d s squared times s plus 1 plus e s squared equals 2s minus 1. And I am going to multiply all that out. As times s cubed plus 3s squared plus 3s plus 1 plus b times s cubed plus 3s squared plus 3s plus 1 plus cs squared times s squared plus 2s plus 1 plus ds cubed plus ds squared plus es squared is equal to 2s minus 1. And a little bit more here. As to the fourth plus 3as to the third plus 3as squared plus as plus bs to the third plus 3bs squared plus 3bs plus b plus cs to the fourth plus 2cs to the third plus cs squared plus ds to the third plus ds squared plus es squared equals 2s minus 1. Now this is where I'm going to set up a matrix, and hopefully you did something like this in pre-calculus. I'm going to every degree here, show you I'm setting this up. So this is my equation for my s to the fourth terms, my s cubed, my s squared, my s to the first, my s to the zeros, and I have a column for a, b, c, d, e on the left-hand side, and then whatever my value is for my solution on the right-hand side. So for instance, for my s to the fourth, I have an a, I have one a s to the fourth and one c s to the fourth, putting zeros as placeholders, rest of the row. And then do I have any s to the fourth on the right-hand side? No. So for my s cubes, I have, and so that was a and c s to the fourth. My s cubes, I have 3a plus just the 3a, 1b, and 2c, and 1d. And there's a 0 for those on the right-hand side because I only have s's. And let's go ahead and fill this in that this is 2 and -1. All those are zeros. For the s squareds, I have 3a s squared, 3b s squared, 1c s squared, 1d s squared, 1es squared. So 3, 3, 1, 1, 1. For my s's, I have 1a, 3b, and that's it. And for my constants, I have just b. So when I set this up in my calculator in my matrix menu, and this is going to be 1, 2, 3, 4, 5 rows by 6 columns to set this up. I'm going to call this matrix A in my calculator, and then I'm going to use the reduced row echelon form command in my matrix menu, the second matrix math that's down towards the bottom of the list. Then go back into my matrix menu and recall matrix A. And it's going to spit out a a new matrix for me that looks like this, that has the identity matrix 2, 3, 5. And it has my answers for A, B, C, D, and E. And it says that those are -5, -1, -5, -4, and -3. Let me just check that real quick here. I think that's correct. 5, -1, -5, -4, -3. That's correct. So knowing that information, that tells me that A equals 5, B equals -1, C equals -5, D equals -4, E equals -3. Then I have enough information to write Y, capital Y of S is equal to 5 over S minus 1 over S squared minus 5 over S plus 1 minus 4 over S plus 1 squared minus 3 over S plus 1 cubed. The only one that's going to need a little bit of adjustment is going to be that last one, that I need a 2 factorial in the top here and a 1 over 2 factorial here. So my y of t is going to be 5 minus t minus 5e to the negative t minus 4t e to the negative t minus 3 over 2 is 3 halves t squared e to the negative t. Let's move on and do some initial value problems before we finish this up. Starting with number 21. Y prime plus 4y equals e to the negative 4t. Y of 0 is equal to 2. So this is S of capital Y of S minus Y of 0 plus 4 capital Y of S is equal to 1 over S plus 4. So this is S plus 4 capital Y of S minus 2 equals 1 over S plus 4. So this is S plus 4 capital Y of S is equal to 2 plus 1 over S plus 4. And then this is capital Y of S equals 2 over S plus 4 plus 1 over S plus 4 quantity squared. So Y of t is equal to 2e to the negative 4t plus t e to the negative 4t. Look at number 23. This is y double prime plus 2y prime plus y equals 0, with y of 0 equaling 1 and y prime of 0 also equaling 1. That gives me s squared capital Y of s minus s lowercase y of 0 minus y prime of 0 plus 2s capital Y of s minus 2 lowercase y of 0 plus capital Y of s is equal to 0. That makes this s squared plus 2s plus 1 capital Y of s. And then we have minus s. And then we have minus 1 and minus 2. It's going to be minus 3 equals 0. So we have s plus 1 quantity squared. Capital Y of s is equal to s plus 3. Capital Y of s is equal to s plus 3 over s plus 1 quantity squared. And I'm going to make that s plus 1 plus 2 over s plus 1 quantity squared, which is 1 over s plus 1 plus 2 over s plus 1 quantity squared. So my y of t is going to be equal to e to the negative t plus 2t e to the negative t. Let's look now at number 25. That is y double prime minus 6y prime plus 9y is equal to t, with y of 0 equal to 0, y prime of 0 equal to 1. So this is going to be s squared capital Y of s minus s y of 0 minus y prime of 0 minus 6 s capital Y of s plus 6 y of 0 plus 9 capital Y of s is equal to 1 over s squared. So let's go ahead, and all of my y of 0 terms are 0. Factor s squared minus 6s plus 9 capital Y of s. Then this is minus 1 is equal to 1 over s squared. So I'm going to add 1 to both sides. When I do that, I have s minus 3 squared capital Y of s is equal to s squared plus 1 over s squared. So capital Y of s is equal to s squared plus 1 over s squared times s minus 3 squared. And so this is going to be a over s plus b over s squared plus c over s minus 3 plus d over s minus 3 squared. And so this is a times s minus 3 squared plus b times s minus 3 squared plus cs squared times s minus 3 plus ds squared is equal to s squared plus 1. Let's go ahead now and expand everything. So we have as times s squared minus 6s plus 9 plus b times s squared minus 6s plus 9 plus cs cubed minus 3cs squared plus ds squared is equal to s squared plus 1. That is as to the third minus 6as squared plus 9as plus bs squared minus 6bs plus 9b plus cs cubed minus 3cs squared plus ds squared is equal to s squared plus 1. Again, this would be a good one to use some matrices on. So let's go ahead and do that with my s cubes, s squareds, s's, and s to the zeros. We have a, b, c, d, and solution. So s cubes, we have one of them here for a, and one of them there for c, and we don't have any here or here. We have none there. For s squareds, we have negative 6a, we have 1b, and we have negative 3c, and we have 1d, and we have 1 s squared on the right. We have 9a, and we have negative 6b, and we have no CS's, no DS's, and no S's on the right-hand side. And we have 9B, A's, 0, 0, 1. And we're going to RREF that. And we get 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And we get for A, B, C, and D, I get 2 over 27, and I get 1 over 9, negative 2 over 27, and 10 over 9. So that gives me my capital Y of S is equal to 2 over 27 times 1 over S plus 1 over 9 times 1 over S squared minus 2 over 27 times 1 over S minus 3 plus 10 over 9 times 1 over S minus 3 squared. No adjustments need to be made. Y of t equals 2 over 27 plus 1/9 t minus 2 over 27 e to the 3t plus 10 over 9 te to the 3t. Let's look now at number 27. Y double prime minus 6y prime minus 13y equals 0. Y of 0 is 0. Y prime of 0 is -3. So we have s squared capital Y of s minus sy of 0 minus y prime of 0 minus 6s capital Y of s plus 6y of 0 minus 13 capital Y of s is going to be equal to 0. And my y of 0 terms are 0. And I have s squared minus 6s minus 13 capital Y of s. And then minus a -3. So this is, I'm going to complete the square here. S minus 3 squared. And that is, this is a plus 13 plus 13 plus 13, so plus 9 and plus 4 more. Capital Y of s is equal to, and that was a minus a, this is right, plus 3 equals 0. So that is s minus 3 squared plus 4. Capital Y of s is equal to a -3. And then capital Y of s is equal to a -3 over s minus 3 quantity squared plus 4, which is a -3 times then s minus 3 squared plus 2 squared. So I need 2 and I need 2 so that my y of t is equal to -3 halves. And then this would be sine of 2t, and I have an e to the 3t multiplied by that. I have one more problem here for you before we finish this video. We'll come back and talk about the second translation theorem next time. So y double prime minus y prime is equal to e to the t cosine of t with y of 0 equal to 0 and y prime of 0 equal to 0. So s squared capital Y of s minus s y of 0 minus y prime of 0 minus s capital Y of s plus y of 0 is equal to, cosine is an s normally there, And normally an s squared there. These are going to be replaced by s minus 1s. And then plus 1 squared is 1. So let's go ahead and expand that on the right when I condense on the left. My y of 0, my y prime of 0 terms are 0, leaving me with s squared minus s capital Y of s equal to s minus 1 over s squared minus 2s plus 1 is plus 2. And this is s times s minus 1 capital Y of s is equal to s minus 1 over s squared minus 2s plus 2. S minus 1s will cancel out on both sides, leaving me with capital Y of s is 1 over s times s squared minus 2s plus 2. And that's going to be a over s plus bs plus c over s squared minus 2s plus 2. We have as squared minus 2as plus 2a plus bs squared plus cs is equal to 1. So my s squared terms are a plus b equals 0. My s terms are negative 2a plus c equals 0. My constants are 2a equals 1, so a equals 1/2. If a is 1/2, b is a negative 1/2. And if a is 1/2, then negative 1 plus c equals 0 and c equals 1. It's drawing. Stop. So now we have y of s is equal to 1/2 over s plus a negative 1/2 s plus 1 over s squared minus 2s plus 2. So let's split that. To y of s is equal to 1/2 times 1 over s minus 1/2 times s over s minus 1 squared plus 1, then plus 1 over s minus 1 squared plus 1. So I need to make a minus 1 up here to match this. So I just added 1/2 because negative 1/2 times negative 1 is a positive 1/2. So I need to subtract 1/2 to balance it out. So this is y of s is equal to 1/2 times 1 over s minus 1/2 times s minus 1 over s minus 1 squared plus 1 squared plus 1/2 over s minus 1 squared plus 1 squared. So my y of t is equal to 1/2 minus I wrote my 2 backwards there. Minus 1/2 e to the t cosine of t plus 1/2 e to the t sine of t. And that will be it for this video. Like I said, next time we'll come back and talk about 7.3.2, which is my second translation theorem, and which is translations on the t axis, and we'll be talking about we'll be talking about a new function, the unit step function, when we come back next time. So see you for the next video.